All right, let's take a look at our synovial joints. First of all, if we were to do a functional classification of a synovial joint, all of them are diarthroses. That means that they're all highly movable joints. The other interesting thing about a synovial joint is that the two bones that are forming the joint don't actually come in contact with each other. What? They don't touch. And technically, you can think of them as like the joint exists in this little pouch, this little egg pouch, filled with what kind of fluid? Filled with synovial fluid. Produced, if you had to guess, knowing what we know about membranes, who do you think produces the synovial fluid? You are correct if you said that a synovial membrane produces the synovial fluid. Okay, ready? Let's do this. So the synovial joint, basically connecting two bones, is like a little egg sac. It's like a little sac. And you have the synovial membrane, and the synovial membrane is producing what? Synovial fluid, which fills this space. So this is actually a membrane structure that is surrounding these two bones, and it's producing fluid, and that fluid provides some cushioning. That works for you, doesn't it? You also have articular cartilage surrounding the ends of the long bones that are forming the joint. And if you look at your pictures of bones in the textbook, this is articular cartilage. And the articular cartilage is actually, its purpose is to provide some cushioning, some support, just in case the bones do whack together if you're running really fast. That wouldn't be a good thing to have your bones whacking together. The synovial membrane, if you think about membranes other than the cutaneous membrane, the synovial membrane is equally as thin and wispy as a serous membrane or a mucous membrane. Like, there isn't a whole lot of structural support in a synovial membrane. So there is also a layer outside of the synovial membrane still surrounding the joint capsule or the entire articulation, and this is called the fibrous layer. And together, these two things, the fibrous layer and the synovial membrane, together they form the joint capsule. And does that work for you? Does that make sense? That, I mean, a joint capsule is, a capsule is surrounding it. It's forming a little space around our two bones. It's forming a little pocket around our articulation. And the joint capsule is made up of the fibrous layer and the synovial membrane. If we had a joint capsule that we could actually look at, we would know that outside that structure, if, for example, I were to stick a pin in it, if I were to stick a pin lying on top of the joint capsule, it would be touching the fibrous layer. And if I were to open up the joint capsule and peek inside and say, hello, little bones in there, and then I stuck a pin on the inside surface of the joint capsule, I know that I would be actually touching the synovial membrane. What else? We have, sometimes you end up with like ligaments that connect your two bones, and they can help stabilize that synovial joint. So a ligament can be in there to help stabilize things. Sometimes you have tendons. Okay, brace yourself for my drawing to get really crazy. This is a muscle. Whoa, what? I'm drawing you all the possibilities. Sometimes a muscle is attached to the bone, crossing a joint in such a way that it actually stabilizes the joint. So this would be a tendon. So tendons and ligaments can actually stabilize joints. Sometimes, for example, in the shoulder, we actually are going to learn some muscles that their exact positioning is set up to stabilize the very unstable shoulder joint. All right, I think that's it. I think that's it. That is good enough for me for what you should know for the structure of a synovial joint. Now we're going to look at, okay, we had what? 2 different kinds of cartilaginous joints and 3 different kinds of fibrous joints, and we actually have 6 different kinds of synovial joints. Shall we?